Hey, what's up? It's Yoshi, the college toy collector, and this is an update on my animatronic figure Atlas. There's quite a bit going on, quite a bit not. There's a lot of things that aren't here anymore, but I'm going to walk you through stuff in this video. Hopefully it is good. I'm gonna do my best to make it good. Currently living at my boyfriend's house, so if you're wondering what's with the change in scenery, that's what it is. So I brought Atlas here so I can work on it. I'll show you what's up. I'm going to give you a bit of a tour of what I've done so far, explain some things that haven't been done yet, and I'll do some things on camera as well. First off, as you can see from just Atlas standing right here, one, he's headless, but two, he's completely stable, which is something that the first iteration / prototype was not, and that is because I've since learned a lot about how I want to redesign specifically the waist. This right here is Atlas's current waist assembly. As you can see, a lot has changed since the prototype figure that you've last seen. I will walk you through some of the stuff that I've done. First off, this is a 3/4 inch diameter aluminum shaft. This is the same shaft that I used the first time around. Only difference is it has been machined on a lathe, so I've simply trimmed the diameter of this to be exactly 3/4 of an inch or 0.75 inches, because when you buy these shafts from the hardware store or from a metal supplier, the tolerance is not very tight. So it's supposed to be 3/4 inch. When the tolerance isn't tight, that means that the measurement can be off by a certain amount, and to get them affordable, the tolerance is not tight. So if you want to not pay a lot of money, you're gonna get a shaft that you're probably gonna need to do some work on yourself, because bearings, on the other hand, ball bearings and shaft collars, their inner diameters are pretty much right on the dot. The precision is a lot more precise than the outer diameter of the shafts. So you do need to do that extra bit of work and to trim like about 1/1000th of an inch off of the diameter of the shaft. And it looks shinier now than it did before. It used to be kind of a matte finish like this. As the cutter takes the layer off, it kind of just creates a shiny surface. And if you wanted to do a different surface finish, you could. I left it alone. It looks fine as is. This here is a pillow block bearing. This used to be a 3D printed part that I made on my original figure, but the issues with that was that it didn't allow freedom of rotation about the z-axis, so I'm calling this the z-axis. There was no freedom of rotation because it was just a solid piece, so I needed something that rotated. A bearing rotates, so now this does rotate freely because this bearing allows it to. Pillow block, I don't know why it's called a pillow, but I would assume because it holds this in place. This pillow block bearing is able to be bolted to the waist down here, and then it's able to hold the rod perfectly in place, so it creates a lot of stability, as you can see right here. I also have another point of contact with the shaft down here. This is so that it takes a little bit of the stress off of this bearing, because if it weren't for this bearing would be doing all the work. It'd be holding all of the force of this rod wanting to go this way. So it's important that you constrain things so that they only move in the way that you want them to. So I only want this shaft to be able to rotate about the z-axis. I don't want any translation about the x or y-axis. Right now, it's actually just the same diameter as the rod, and it's not scratching up against it at the moment. If I were to use this regularly, it would be best to have a roller bearing in here, because anytime something rotates within an assembly, you typically want some kind of component that allows it to rotate freely so that there's no additional friction that would cause wear over time. So at the moment it's working, but I will eventually put a needle roller bearing in here. This part that you're seeing right here is a newly machined part that I made on a mill. I used a bandsaw and a mill pretty much, and this is just raw material that I did show in the previous video where I kind of reintroduced this project, and I showed I had a raw material that I got from a metal supplier nearby, and I simply just machine this out. What I do is I make a engineering drawing of the dimensions and how I want it to work, so that way it holds exactly how I want it to. I cut this slot in here so that it fits perfectly with the cylinder mount that I also designed. This is my design that I made for this specific cylinder, and then it has a ball bearing in there, and it fits perfectly between this slot. This is very strong. I'm very happy with how this turned out. That is basically the same part as this part. So this is the 3D printed part that I first made to test out the length of this as well as just the functionality to see if this would work. I did make this like 50% infill, and I designed it in such a way to where it would maximize strength. But for the longevity of the figure, I wanted this piece to be made out of metal, aluminum in this case, so that way it should last, because, you know, over time plastic is going to have, you know, fatigue. I was also pleasantly surprised to find out that machining these parts are not difficult. So my friend and I have been going to the machine shop about twice a week, and I've been bringing in my engineering drawings with all the dimensions and everything, as well as sometimes if I do have the 3D printed part to show, I bring that with. And I've been learning how to use the manual mill and lathe, and I'm getting pretty good at it. And it's good to know that a lot of the parts that I want to make are actually very easy to make. Like this was not challenging at all. It's just a slot. There's a hole cut through here. And then I'll show you on the back of here, there is set screws. But right now, I don't think I have any set screws in place because this shaft collar actually holds this pretty tightly. This here is what the set screws look like on the back of that part that we were just looking at from the front. They are threaded. I learned that you can thread holes by hand with a tap. I'll show you how to do that in either this video or another one because there are more parts that I have to do that with. But this here is what this looks like. As you can see right now, I don't even have any set screws in there because the shaft collar is doing all the work at the moment. My friend told me when it comes to metal, if you have a very tough and sturdy material, you can just do set screws. Clamps are used more for softer materials like plastic. They can be done on metal, but it's not necessary, and this is completely fine. Ignore these tension springs right now. I had an idea, and I don't know if I'm still going to go through with it, but they are just there. We'll see if I end up doing anything with them. Right now, they are simply just on the back of the figure. The legs are also wider. They're further apart than the torso. Originally, the legs and torso were the same width apart. The legs are now further apart to give more stability. And then as you can see with my upper waist bar, this piece right here, I also have a set screw here. This is a threaded hole that I made. And this is so that this screw, or it's a bolt in this case, can hold the shaft in place so that the upper waist turns with the entire lower waist, because that's what I want it to do. I don't want this to freely rotate and this to freely rotate. I want them to rotate synchronously. So I have this bolted here in place so it does that. And then there is also a shaft collar below to hold this at the level that I want it to be held at. Another thing that you're probably noticing as I'm showing the waist is that these bars are both thicker material, and that's because they are. This is a 1/2 inch thick. This is, I want to say, 3/8 inch thick. This is a 1/2 inch thick, so that way I was able to put the 1/4 inch threaded hole through this with material to spare. That's why it's thicker. And then this is just 3/8. I didn't need to drill anything through this side, so it was fine. But it's thicker and sturdier, as you can see. I have replaced a few of the parts with thicker material, and I will continue to do that. This is a 5/16 inch diameter bolt, and these are partially threaded bolts. You can get them at Lowe's, and what's great about them is you're able to have the threaded part in the area that you want to fasten and secure to, say, this piece, and then you're able to have a just regular shaft for putting a rod end on, which is what I want to do. So I have this piece here. I measured this out so that it turns perfectly, so that way when I have the 2 cylinders back to back, I measured it perfectly out to where it turns in the exact way I want to, depending on which cylinders are activated, which ones aren't. You can kind of see in the back too, there is an additional, there's another one of these back here, and there's another thing back here. Now, what I think is pretty neat about this assembly right now is this is my old part, as you can see. This has not changed, but I do have the entire metal part for this, just not assembled yet. As you can see, this part is holding this up. I'm very pleasantly surprised by that, because this is quite a bit of weight. This is the weight of the torso. Granted, not everything is on the torso at the moment, but for what it is holding it in place, my old assembly right here. And this part that I designed was mostly just so that I could figure out the angle at which I want this part to face downward, to where it, one, can reach the end of the cylinder and have this be vertical, but also it needs to maximize strength. So if it's completely horizontal, there's a huge lever arm there that creates a lot of stress at the very end that can result in the piece failing. But if you make it too angled, then you have the issue of the cylinder not being vertically oriented. So you want an angle that works perfectly so that it maximizes strength to where this pushes up. It won't break this piece because the angle is allowing for strength in this direction, but it's also at an angle to where this can be oriented how I want it to be. I'll try and explain this better. When I eventually place my new part on there, I can explain better on how I do that, but that's kind of my explanation as of right now. Also, currently, there is just a random bolt holding this in place. That is not going to be what I end up using. It's just there to keep this all together. Things aren't even fully put together anyway. As you can see, I don't even have things like fully in. It's just for the sake of seeing everything come together. This is the next thing that I'm taking apart, so that's why it looks like this as of now. That's why this isn't fully in. There's some stuff missing, because this is completely getting replaced. That's the second thing I plan on doing in terms of this whole assembly. The C hinges here on the bottom, I am keeping because I don't need to really machine those. These work perfectly fine. They're probably 50% infill. I made them a long time ago. They fit the ball bearings very well. I got 1/4-inch shafts in there, so they completely securely fit in the ball bearings, so that way it rotates with the bearing and it's not the shaft moving. And it's able to hold up the weight. You don't need a metal part for that, so that's why I'm keeping those. And then we are almost done with the tour of how the figure looks so far. And then I could finally do some of the parts of the video where I show you some of the things I got and put some things together. There's still a lot missing. I have these newly machined torso dividers, whatever you want to call these parts. The holes are big enough to fit a needle roller bearing through there. So then that way there is a secure contact with the 5/8 inch diameter shaft that's through here. And this is matte finished because my friend decided to sandblast it. I'm fine with that because the rod itself isn't what's rotating, it's the bearings that are rotating it. So sandblasting just gives it that matte finish. You don't want to sandblast something if it's the rod itself that needs to move. But because bearings are doing all the moving, I really didn't care. But I just thought it was funny that it's sandblasted now. That's why it's matte finished. But yeah, pretty much the entire head turn assembly is not there because I'm completely redesigning it. It's still within the drawing phase. When I design things, I draw on paper first. I just sketch a bunch of things out until I like it. Then I start slapping dimensions on, and then I'll model the parts on the computer and we'll test it out. So I'm completely redesigning how this head turn's gonna work. So that's why there's nothing there except the shaft that is going to have the neck and everything attached to it. I do plan on machining the E hinge and C hinge that will attach the head. I was originally not gonna do it because it doesn't really matter. That's not a part that needs to be made out of metal, but it's easy to do. I feel like I'm almost done with all the parts that I plan to make, so might as well. Like if I really wanted to, I could also machine this piece, which is another part that doesn't need to be, but I could if I felt like it. As for this piece, this will be completely changed out because I did entirely redesign this. I could show the engineering drawing on screen right now. If you're wondering why I call them engineering drawings, it's because in the industry, nobody calls them blueprints. I don't call them blueprints. They're not blue. I've always called them engineering drawings. I'm a teacher's assistant for a class that teaches engineering students how to properly do them, and they're called engineering drawings. So that's what I call them. You can call them mechanical drawings, I don't know, technical illustrations, engineering drawings, whatever. That's what I call them when it shows the top, front, right side view and an isometric view so that you can see what the part looks like, and everything's fully dimensioned correctly and according to geometric dimensions and tolerances. So fun, so exciting. Half joking, half not. But anyway, My friend and I were going to machine this. I was originally just going to ask my friend to print it on a resin printer because you can get resin that's really strong. And I was like, oh, we can do that. But then we both figured that it would actually just be easier to machine it. We're planning multiple different ways to do it because if we decide to machine it out of one big thick piece of material, there's going to be so much material wasted that it just makes no sense to do it because you're going to have to cut out all this. So what I'm thinking of doing is machining just this half that includes this and then includes the front here, and then machining this separately, and then having threaded holes that allow this to be secured on from this side, and then that way you're not wasting material and it should be not too difficult to machine. We could weld it. I think you can TIG weld aluminum. Aluminum is harder to weld than steel, but so far I've designed everything to be able to be secured with bolts and with non-permanent fixtures, for lack of better terms. So I think it should be fine if we do that method where we machine one part, machine the other part, put them together. I like that idea. I still like this design. I don't plan on changing it. This is how I like it. Both of these are also partial threaded to where the parts of the bolt that are going through either a rod end or a cylinder end are not threaded. They're bare like how I showed you in the waist. So, yeah. This here is the right arm assembly. This is done, unless I want to clean it up in any way. You will notice I did decide to keep all of the square tubing that I used previously because I didn't see a reason to just get rid of material and restart simply because I'm redesigning things and making it better. I'm deciding to use them, so there are still random holes that are there, so cosmetically it doesn't look the greatest, but I still think it looks pretty good. And there's just no reason to scrap pieces just because I want things to look flawless or whatever. I think this still looks pretty nice. As you can see, it's the same design because I do really like the design that I had to begin with, but it's more streamlined so that it looks better. So it's smaller, my C-hinge here is smaller. I have a very tiny piece here that's holding these two clamps in place that hold the arm here, and then this cylinder is still holding this up. This mount down there that's holding this cylinder, I do plan on making that thicker material as well, so that will also be replaced. And then as for the forearm that you can kind of see, this is the same exact, that's the same exact linkage. This is a brand new piece that just streamlines the old one. This cylinder here also has a 4mm inner diameter hose now, so I now have 6mm and 4mm inner diameter hoses. For the cylinders that aren't going to be moving as much weight, I'm just going to have a smaller hose diameter because you don't need one that's that big. So, as for the head turn assembly, I do want to challenge myself to design it in such a way to where I do not have to drill any new holes into the torso. I can only work with what I have already, meaning this distance between these bolts and that bolt have to be utilized in some way if that's what I choose to do, or if I'm only using these top ones, I have to figure out a way to where I can utilize what's already here because I don't want to make any more changes to the torso. And I think I can do that because my design has a back-to-back cylinder design that is probably going to be mounted on one of these in some way, we'll see. Or it might be mounted onto this one, but we'll see. That's going to be the last real added mechanism, I guess, to this particular figure, because all the other things are designed, they just have to be built and put together. These bolts right now, they're 3/8 inch diameter. They are filler bolts because I do have just a long threaded rod that's 3/8 that are gonna go in these spots, and they're meant for the eventual body shell if I want to ever do that. Right now, my main focus is just getting this figure done and working because that would be great. But if for whatever reason I do continue it at some point, I did think ahead as to how I'm going to attach a body shell, and these are holes here so that you can put, long rods that go out the back and out the front so that you can attach it like that. Overall, this figure is very sturdy. That was one thing that the original one was not, but the original one was also the first time I've ever built something like this, so I was learning as I went. I've since learned a lot and have applied that knowledge to redesigning this figure, which is the same one, but better, if that makes sense. And that's how engineering goes. Engineering, you make many iterations of something until it satisfies you or your client, depending on what you're doing. This is just a for fun project, personal for myself. It has gotten me a job though. This here is one of my SDA cylinders that I have that I'm using for movements that, you know, are shorter. Has a shorter stroke, wider bore. It's a different body type. This is the same mount that's on the body lean cylinder at the moment. And I designed this because I couldn't really find one that was good. I still need to change out these for M6 by 1, and that's also what I'm going to do here. And I'm going to show you the plan that I have for this, because I have this idea and I want to see if it's going to work. So the issue at the moment is that this is an M6 by 1, and that means that this is only 6 millimeters, which is small for what I'd like it to be. I'd like the shaft that this attaches to be bigger so that it's stronger. This here is an M8 by 1.25, so that means this is an 8 millimeter inner diameter, and that's what I want this to be. The issue here is that this is 6 millimeters, and these are in metric units, so unfortunately I'm dealing with both metric and imperial units, which is fine. It's just a lot of converting back and forth. This is also something interesting that I did, as you can see here, is that this originally has an inner diameter of M6 by 1. So I simply took a M6 by 1 threaded rod and put it through here, and it acts as a middleman between this and this. So I have since took off the rod end, and now this is just my M6 by 1 threaded rod. And this is a reducer. It's technically an M8 by 1.25 reducer to M6 by 1, but I'm technically using it as an expander, for lack of better terms. So this should screw on just like this. Yes, it does. And when this screws on to this 6 millimeter rod, I should now be able to take my 8 millimeter rod end and fit this over. Yes, I am. I love when my plans work out. Oh my goodness. This is very satisfying. Do that again with this one, and then there's just one other one that I have to do. This is an M6 by 1 thread. I should also note this is right-handed. There are right-handed and left-handed threads. Right-handed are the more common. So make sure that if you're going to do it, it's the same. So this also has to be right-handed. This is my reducer from M8 by 1.25 to M6 by 1. I put it on here. I absolutely love when my ideas work. It's fantastic when it works in my head and it works in real life. Now I'm able to put my 8 millimeter rod end on. And this is literally just so that I can get this 8 millimeter diameter, which allows me to use the 5/16 inch diameter rods that I have on the body right now, which just creates a stronger connection. It's so that it's not as weak, because the thicker the diameter of the shaft, obviously the stronger it's going to be. So now I'm able to use 8 millimeters with this. So now these two cylinders are going to be my waist turns. I'm going to mount them back to back, and now they have their 8 millimeter rod ends, which is fantastic. I purchased these M6 by 1 machine screws, or whatever you want to call them. They have the Allen wrench style top or whatever. I got these on Amazon. We're gonna see. They should be long enough to be able to thread all the way through both of these cylinders. The one thing that's unfortunate when you live in America is, for some reason, metric unit anything is more expensive, because America likes to live in their own world and use the imperial system. So anytime you get something metric, it's going to be a little more expensive, but that's fine. We'll see how this works. Hopefully it works well. So far everything has been going as planned. Thread this through the holes, and it is going through. I unfortunately ran into an issue with this plan. I've discovered that these holes are not threaded all the way through. They're only threaded in the beginning, and the beginning of this, they're not threaded towards the middle. So I can do one of two things. I'm thinking only the one thing, actually, now that I think about it, is I need to thread this all the way through myself, which should be fine, because I want to say this is an aluminum housing. I should be able to do that, but I'm going to have to get an M6 by 1 tap so that I'm able to thread this myself. And I just said that metric things are more expensive in the United States, so that is fantastic. But, you know, there's all kinds of bumps in the road, and you just gotta problem solve and figure out what to do next. So, okay, I'm gonna have to wait on mounting these back to back at the moment, unfortunately. At least one of the things worked perfectly as planned, my 8mm rod ends. So at least I got that going for me. But I'm going to have to thread these holes, so we'll do that in another video, or I'll just show you when I do it. Here are just my 5/16 inch inner diameter shaft collars for when I eventually am able to put those cylinders on the waist assembly. In this very crusty bag are needle roller bearings. These are the ones for my 5/8 inch outer diameter shaft. That's the neck shaft that I showed you earlier. That's what these are. I'll be putting these into the torso dividers that I showed you before. I also have this whole bag of hose reducers that I will be using for any of the parts on here that are using the 4mm inner diameter that need to be converted back to the 6mm that I want the standard of all of the hoses to be, so that the valve bank all has the same diameter hoses, and the diameter only changes on the figure for the cylinders that need it. This here is actually the new body lean bar. The metal supplier wrote all that on the back. This is what is going to be used for that plastic part that I showed you that has the body lean cylinder and everything. This is what the new bar looks like. I have the angled piece too, so I have the threaded holes here. That's how it's going to be assembled. Here's just an idea of how I draw things out. So when I'm just marking up material, very simple pieces, I typically just draw it on paper and whip something together. I label it so that way I know what part correlates to what drawing. I usually don't go and make a full computerized engineering drawing for parts that are this simple. So when it comes to hosing a figure, there's a bit that goes on. I personally really like it. I don't know, it can be tedious work for some, but you've got to organize it in such a way to where the hoses kind of trace the outline of the figure. So that way when you do eventually put cosmetics or a body shell over this, you don't got hoses to worry about that are kind of all over the place. So what you kind of do is, like right here, I have my 4mm inner diameter hoses on the right arm, and I traced it up the arm. You don't want it too tight because that will put stress on the fittings. You want to give some clearance, for lack of better terms, and you kind of want to trace it. So what I'm going to do is I'm probably going to go here. I'm going to trace it down the body, trace it all the way down the leg, and then I need to figure out how long I want all my hoses to be, because I don't want the valve bank to be right at the base of this figure. I preferably want it to be kind of further away. So that's what I'm doing right here. These 4mm diameter hoses will also be transitioned into my standard 6mm ones. That way the bank can be entirely 6mm. And you want to make sure when you are organizing these that when there is movement, the hoses also are able to have enough flexibility and they don't get tight anywhere. Even if something moves, you don't want them to get tight regardless of what's moving. So that's what I'm going to do. I use 2 different size zip ties for this figure. I use like small ones and then these bigger ones. The small ones are just to organize the individual hoses themselves. So to kind of put them together here, so then the hoses that go to the same cylinder are all together. So it's easier to trace back in case you have any issues or whatever. And then these bigger ones are to hold it onto the body. So I'm going to put these on right now. I just have both of those hoses that I just showed you. Just literally, they're not even cut yet because I want to see how long I want to make everything. And this here is organized chaos. It looks like a mess, but I have everything sorted out. I'm going to zip tie these so that way I can get an idea of the length that all of that's going to be. This is going to trace down here. And then now I can kind of get a better idea of what that'll look like. So I have this nicely fed through the back. These are all my right arm hoses from before, and I have them capped off so that nothing gets in them. So here's how long I've got this going. I have it going here, and then it changes the adapters, make it 6mm, and then the bank is all the way over there. I turned the cylinder around, which is how it was before. That way the hoses are now facing backwards so that there's less stress on them and then they have more room to fit downward. This is how they look, and then they all get fed down the leg. And this is how much length I have right now to the bank over there. This bank is gonna have an additional 5 spaces added to it. I just have to attach that and build this exactly how I built Duke's bank, but that's what this looks like for now. So that was just an update of what's going on here. I will have another one once I have more of the parts made and everything, but this is what it looks like as of now. This should hopefully be fully complete in December, I would think, just like how it was the last time, funny enough. So December seems to be the month, but it is coming together. It's looking good. I'm liking how it is so far. I just need to do a little more of making parts and then also designing this entire mechanism, and then I'm on to building another figure and then another one and then another one after that. So yep, thank you for watching the update. Stay tuned for more, and I'll see you later.